A relation is a set of ordered pairs. So you can have a relation that's a set of ordered pairs that looks like this. You can have a relation that's a set of ordered pairs that's a graph. You can have a mapping, which we do later. A function is a special type of relation where each x value has one unique y value. And we'll do some examples here in a couple minutes. The domain is the x values and the range are the y values of the function. So example 1, graph the relation. So you want to plot the points, -1, 4, 3, 4, -1, 6, which is off the chart, and then 2, 6. So I plotted these points, these 4 ordered pairs. So is this a function? So for each x is there one unique y. So here's the x. So -1 has a 4, but -1 also has a 6. So 4 and 6 are not unique y's. They're different. So -1 can't have two different y's. So in this case, it's not a function. So no, because -1 goes with a 4 and -1 goes with 6. So these two y's are different. So the domain is going to be the x value. So what you want to do is you want to write it in set notation. So I use a bracket. So this bracket like this, I make a C, and I list out the x values from least to greatest. And then I don't include the same x value or same domain twice. So I don't need to write -1 twice. I'm just going to write -1, comma, the next number is 2 and 3. So that's my domain. I'm going to do the same thing with the range. I'm going to look at the y values, 4, 4, 6, 6. So the range is just going to be 4 and 6. So you can represent relationships different way. We did a graph over here. We did a set of ordered pairs. And now I'm going to take the same relationship and make a mapping. So in a mapping, you want to have your x and your y. And I'm going to list out my domain. So -1, 2, and 3 in my range, and 4 and 6. And a mapping shows the connection to it. So -1 goes with 4. 3 goes with 4, -1 goes with 6, and 2 goes with 6. So I can also tell it's not a function because -1 is going to two different numbers. So it doesn't matter if y has two different numbers, you're looking at x can't have the same number going to two different numbers. Okay, 3, determine whether the mapping is a function, explain. So this would be a function because the 2 is going only with a 6, a 3 is only going with a 6, 4 is only going with a 5, and 7 is only going with an 8. So I'm going to write it as each x has one unique y. Another way you can determine if a relation is a function is by using the vertical line test. So the vertical line test would be, I'll do a few examples, or 4 examples here. So if you have a relationship such as this blue curve, the vertical line test is if you drew an infinite number of vertical lines, then the vertical line would not cross the blue function twice. So each vertical line only crosses the blue once. So this would be, yes, a function. Okay, contrast that with something like this. If I drew a vertical line, I'm crossing the blue function or the blue relationship twice, so it's not a function. Okay, here's another example. This one, if I drew vertical lines, yes, it would be a function, but if I make it go like this, it's going to cross more than once, so no, it's not a function. Okay, we can do a few more examples right here of the vertical line test. So this would be no, this would be yes, and this would be no. So another way that we use functions is using function notation. So you might have seen this in Algebra 1 where sometimes we just have a variable y equals 2x. Other times we can have f of x or g of x or h of x. So f of x means that this is going to be your output, your y, but you're going to input whatever is with x. So if you had f of 2, that means that you're going to plug in 2 for x. So that's 2 plus 5. So every function has an input and an output. So an input is the independent variable and the output is the dependent variable. So example 5. If you have f of x, find f of -1, f of -3, and f of 6. That's how I read it. So f of -1 is going to be 1/3 times -1 plus a half. So I'm going to do one of these. So I have -1/3 plus a half. So remember, when you're adding fractions, you want to get a common denominator. So my common denominator is going to be 6. So it's going to be 3/6 plus 2/6, which is 1/6. So the answer is 1/6. So you could do the same thing with -3 and 6, plugging that in for x in both spots. Okay, both here and here. Okay, -4 times f of 1. So what that means is we're going to do f of 1 first, and then we're going to multiply it by -4. So f of 1 is equal to 1/3 times 1 plus a half. So that's 1/3 plus a half. Now again, I want to get a common denominator of 6. So this is 2/6 plus 3/6, which is 5/6. So -4 times 5/6. So this is -4 over 1 times 5/6. So I can reduce this by multiplying across. Most people are comfortable with multiplying across and then reducing. So it's -10/3. Okay, example 6. The function for a bank account's balance B for an account starting with 100, earning an interest rate of 4% and left untouched for n years can be calculated as below. Calculate B of 0, and what does that mean? So B of 0 means that you replaced n with a 0. So n stands for years. So this means at time equals 0 years, how much you have in your account. So I'll find B of 0. So B of 0 equals 100 times 1 plus 0.04 to the 0 power. Okay, you can put this in your calculator, or I know anything raised to the 0 power is 1, so it's $100. So that means that you're starting out with $100, which we kind of already know at time 0. Calculate B of 15, and what does that represent? So remember, n equals 15, so this means 15 years have went by. How much is in your account? So B of 15 equals 100 times 1 plus 0.04 to the 15th power. So you want to put this in your calculator and make sure that you round to 2 decimal places because we're talking about money. So make sure you have 2 decimal places.